Hello. I've got something to tell you. Okay, today we are in section 3.1 and 3.2. Okay, we're going to talk about minimums and maximums of graphs. Okay, and minimum maximum values of functions. So let's jump into this. My internet's gonna work. Hopefully it does. We can't tell about these things, you know. What the heck? I gotta close this thing out again. Something screwy is going on here. Do you want this to allow apps to make changes to your device? Google Chrome, sure. Yes, I do. I might have to reboot. We'll see. Yay.
Whoa there.
Sorry about that. That was fun. There goes my speakers. Exactly. Okay. Sorry about that. Occupational hazard. So I got my sticker on today. I voted today. I did my civic duty and voted today. It was a very interesting process because I was able to do a mail-in ballot, and it was the first time I've ever been able to sit down with my son and have us kind of like go through the ballot measures together. He's 17, so he just missed the election by 3 months. So we went through it together as kind of a family, and he told me how he would have voted, and I told him how I'm voting, and it was a great civics lesson. So something that probably would not have happened if COVID didn't occur. So, you know, I guess that's kind of like a, you know, one of the you know, positives inside of a huge negative. So anyway, but go out and vote. Make sure you vote. Okay. So do your duty. Okay. Okay. Anyway. Okay. So let's get to it here. Let me share my screen real quick. Okay, I need to add a section. Sorry it's taken so long to get set up today. I'm actually sick. I'm not feeling well, so I usually have all of this set up beforehand, but I'm just not feeling it today. So, chapter 3. So directly after lecture, I'll be crawling back in bed. Good times. Okay. So this is my untitled page. My untitled page is 3.1, 3.2 notes. 3.1 and 3.2 notes. Notes. I did actually, yes. I got the flu shot back in September. So I did get the flu shot. This is not the flu, unfortunately. So it's probably a common cold. No fever. So I know it's not COVID. So yeah, probably just maybe something I ate. Who knows? You never know about these things. But I don't have COVID symptoms, so I know it's not COVID. Or at least I don't have COVID symptoms yet. So, but I don't have flu symptoms either. I'm not nauseous. I just feel I feel achy, if that makes sense. I feel achy and I have a stuffy nose. So to me, that feels like the common cold. Achy, stuffy nose, no fever. So. Okay. 3.1, maximum and minimum values. Okay, so 3.1, maximum and minimum values. Okay, let's look at increasing and decreasing functions. Okay, what happens when functions increase and what happens when they decrease? Increasing, okay, and decreasing functions. Get rid of this guy so it doesn't slow down my internet. There we go. Okay, so what does it mean for a function to increase on an interval? Well, it means that it goes uphill. Okay, this is an increasing function. It means that every point between A and B, as I go from A to B, the values get larger. Okay. What does it mean for the function to be decreasing? Well, it's just the opposite. It means that from point A to B, it goes downhill for every point in that interval. Okay, that function is decreasing on that interval from A to B. And I'll designate that as a minus sign. Okay, think of it as maybe slope, or you're sliding, you're traveling, as you travel from right to left, you're going uphill, and traveling right to left, you're going, or sorry, left to right, you're going downhill. Okay. So this is increasing, and this is decreasing. Okay. Okay, let's let f be a differentiable function, means that it can have a derivative. On an open interval I. What does open interval mean? It just means that we do not include endpoints. We do not include endpoints. Okay, on an open interval. Okay, I. Okay, if I'll say I on an open interval I, call it I for interval. Okay, A. If f prime of x is greater than equal or is greater than 0, if the derivative is positive for all x in I, then f is increasing over I. Okay, it's saying, look, if the derivative is always positive, if the derivative, the slope of the tangent line is always positive, then it's increasing. Whereas if the derivative is always negative, if the slope of the tangent line is always negative, then it's decreasing. Okay. So B is just the similar statement. Okay, the complement of this. If f prime of x is less than 0, it means it's negative. The derivative is negative. For all x in I, then f is decreasing over I. It's decreasing over I. Okay, a critical value. Oops. Value of a function let's mute everybody. Who's unmuted? Christian? There you go. Okay. A critical value of a function, okay, is any number. And we're going to call that number C, any number C, for which either the derivative at that value is equal to 0, or the derivative at that value does not exist. Okay, it does not exist. So if the derivative is equal to 0 at that value, then C is called a critical number. If the derivative does not exist at that value, then it's also a critical number. Okay. So the ones where we get zeros, that's going to help us find our max and mins. Okay, these are the critical values that we're really interested in, are the ones that where the derivative is equal to 0. Because what does it mean for the derivative equal to 0? It means that the tangent line is horizontal, which means that that is where my maximum and minimums occur. if the tangent line is equal to 0, if f prime of c, say that this is c, if f prime of c is equal to 0, then I get a horizontal tangent line which only occurs at a maximum or a minimum. Okay. This would be a min. Okay, and there are relative mins and relative maxes. Okay, they're called relative mins. They're relative to the neighborhood. Relative minimums and relative maximums occur where f prime of c is equal to 0. Okay, they occur where f prime of c is equal to 0. Okay, so it's just saying, look, all of the values around this guy are bigger than what's occurring at c here. Okay, and so we say that, that's a minimum value. And here, all the values are smaller than what's occurring at c, and so that's a maximum value. Oh, okay. Very, very easy. Okay, so if a relative minimum or maximum exist, then at f of c, then cf of c or we'll just say then c is a critical value. Oops, what happened there? Is a critical value. Critical value. Okay, then c is a critical value, and we say that c, oops, come on, behave here. We say that the point c comma f of c is a critical point period. Okay, so we're just saying, look, if there a question? Okay, oh, there's a delay on the writing. Okay, so yeah, let me oh no, not anymore. Great.
So basically, Professor,
Yeah.
So the minimums and the maximums would be considered the critical points of the graph, right?
Correct. So yeah, let me explain that again real quick. Okay, I don't know why this thing is all going wonky on me. Okay, whatever. Okay, so the idea is that here I'm at C, right? C, and that is called my critical value. Okay, that's say, oh, let's just do, instead of C, let's do 2. And let's make it concrete. Okay, say that we're at x is equal to 2. Okay, does it make sense? X here is equal to 2. Boom. And we're going to say that when x is equal to 2, y, okay, is equal to 4. Okay, we're over here at 4. Okay, so we would say that the point 2, 4 is what? It's a critical point. if and only if and only if f prime of 2 is equal to 0. Does that make sense? If that checks, then that's a critical point. Okay? If the derivative at that value is 0, then it's a critical point. And then what do I know? Then I know that 4 had to be a maximum, or had to be a maximum value or a minimum value. Now I don't know which is which, okay, yet, but I do know that it had to be either a maximum or a minimum. Okay. Okay, so how do we tell which is which? Well, we do something called the first derivative test. The first derivative test will tell me for relative, and we call these extrema. Okay, relative extrema, the extreme points. Okay, these are the extreme points. Okay, think max and min. Okay, these are the max and mins. Okay, so the extreme points, they're relative extrema. The first derivative test for relative extrema does this. It says, okay, say that I have this function, okay, have this function, and the vertex of this function, let's say that f of x here is equal to, I don't know, let's see. I could cheat and put this right in the middle if I wanted to. Maybe I'll do that. Okay. How about I do negative x squared minus 4x what do I want? No, plus 4x minus 4. Okay, let's say that we do this one. Okay. Is that right? No, that's not right. Why is that not right? No, there is no middle term. Sorry. This is a plus 4. Negative x squared plus 4. Let's do this one. Okay, I have this negative x squared plus 4. That's going to be this parabola here. Okay, where my x-intercept is going to be at 4. Okay, it's going to be at 0, 4. Okay, that's also called my vertex. Okay, so 0, 4 is my vertex. Okay, now, given that it's a parabola, this is a pretty easy one to see that that's going to be my maximum value, right? Okay, that's going to be my extrema. That's going to be my maximum value. Okay. So what I want to do is I want to take this and find the derivative of this. Okay. The x-intercepts, by the way, if I factor out a negative here, I get x squared minus 4. And then that equals negative x plus 2 times x minus 2. If I set that equal to 0, the original function, that will give me my x-intercepts. So this x-intercept is at negative 2. And this x-intercept is at positive 2. So that gives me my x-intercepts. Setting the original function equal to 0 gives me x-intercepts. Setting the derivative equal to 0 gives me my extrema. This is my extrema locator. Okay, so setting the function equal to 0 gives me my x-intercepts. setting the derivative equal to 0 gives me my extreme values. Okay, keep that in mind. Those are my critical values. Okay, so let's find the derivative of this. What's the derivative of the function that I have here? This derivative. What's the derivative going to be?
Negative 2x.
It's going to be negative 2x. F prime of x is equal to negative 2x. Okay. So that's the derivative, right? So let's set that equal to 0 and solve for x. So what is x going to be equal to here? Thank you, Oscar. It is 0. You are correct. So I need to stop my sharing for a second because this thing is all over the place. Okay, share my screen. It did the same darn thing. Okay, whatever. Who cares? Okay. So yes, x is equal to 0. Okay, x is equal to 0 here. Okay, so where does that tell me? That tells me that when x equals 0, a minimum
is by the author.
Say that again. A minimum or a max occurs. Now, is this true? Did a minimum value or a maximum value occur when x equals 0? Yes. It was the vertex, right? The vertex, which is the highest point here, occurred. So what is my maximum value here? My maximum value is f of x equals 4, right? Well, how did I get that? Well, I plug in 0, right? So let's take my maximum value is equal to what? Well, it's f of 0, and let's plug in 0 into the original function. Well, that's negative 0 squared plus 4, which is 4. So what's my maximum value? My maximum value is equal to 4. Okay, what's my minimum value? Well, there is no minimum value. Okay, I only got one critical value. Okay, so there is no minimum value, which makes sense because this is a parabola. Okay, it would make sense that there is no minimum value. Okay, and so there is a maximum value here. But again, how would I figure out if this was a maximum or minimum without the graph? So without the graph, how do I know if 0, 4 is a maximum point or a minimum point? And what I do is I test the points around this. Okay, I test the points around my critical value. Okay, so we're going to look at a number line and we're going to say, oh, well, what was my critical value? C was equal to 0. So let's test some points around C equals 0. And what I'm going to do is I'm going to use the derivative, the first derivative, f prime of x, to give me information about the slopes of the tangent lines. So at negative 1 and 1. So I'm going to say f prime of negative 1. Let's see what's f prime of x first. F prime of x is equal to negative 2x. So f prime of x is equal to negative 2 times negative 1. Sorry, f prime of negative 1 is that, which is equal to 2. Oh, okay. And what does that tell me? That tells me that the slope is positive at negative 1. Well, when we had our critical value, okay, f prime of 0, that was equal to 0, right? F prime of 0 was equal to 0. And so this told me that the slope at 0 is 0, right? So the slope of 0 is 0. The slope of the tangent line is 0 when x is equal to 0. So if I were to look at, you know, the derivative values here, I would say that the derivative is 0 at 0. The derivative is positive at -1. If I were to plug in 1 here into the function, I would get -2, and so the derivative here is negative. And so this goes from a positive slope to a negative slope going through a 0 slope. Now, what shape does that? It's this shape here, where if I'm at 1, I'm a positive slope. When I'm at 0, I'm at 0 slope. And when I'm at negative, or when I'm at positive 1, I'm at a negative slope. And so what would this force this critical value to be? Would it force it to be going from going from positive to negative as I move from left to right, going from positive slopes to negative slopes would force this thing to be a maximum value. And that's called the first derivative test. Okay, we test our critical values and we say, each side of these values, what's happening? Okay, so let's do one more like this. Okay, I'll call this example 1. Okay. Let's do example 2 here. Okay, find all extrema. Okay, find all relative extrema of f of x equals 4x cubed minus 9x squared minus 30x plus 25. And I'm going to do all of this without graphing because graphing is a pain unless you have, Desmos and you can have these things graphed for you, then it's not as much of a pain. But if you're in a traditional classroom, graphing would be a pain. I don't want to find all the maximum minimum values if I don't have to using a graph, because then I just end up plotting a ton of points that I really don't need to plot. Okay, so what are we going to do? We're going to want to find our critical values first. So step 1, find our CVs. Okay, let's find our critical values. So what are we going to do? We're going to take the derivative and set it equal to 0. Okay, take the derivative, set it equal to 0. Okay, so this is a polynomial, so the derivative is not going to have anywhere that it's undefined. Okay, but it will have places where the derivative is equal to 0. Okay, so this is going to become, bring this 3 down, and this becomes 4 times 3x squared minus, this is going to be 9 times 2x, right? Bring this 2 in front, take the derivative of that, minus 30 is equal to 0. Okay, so this equals 12x squared minus 18x minus 30 is equal to 0. Now that's a polynomial, and I want to solve this polynomial. Okay, so I noticed that each of these is divisible by 6, or I could, let's just factor out a 6. I noticed that I can factor out a 6 from each of these terms. So that's my greatest common factor is 6. So I'm going to go 2x squared, okay, minus 3x minus 5, okay, is equal to 0. Okay, so now what can I do? Well, I can divide by 6. Okay. And I get 2x squared minus 3x minus 5 equals 0. Now I have to factor this thing. Okay, that's the F word in math. Nobody likes to factor. There's 2 F words in math. We try to strict them from the mathematical language because they're obscene. One of the F words that nobody likes is fractions. Makes people scared when I say that word. And the other F word in math that people don't like is factoring. They don't like it when I say factoring either. That makes them extremely scared as well. So two words that make algebra students run in fear and go hide in the bushes is fractions and factoring. And then if I bring them together, if I want to factor fractions, they roll over and like huddle in the corner in like the fetal position, right? And it's like, no, don't make me factor fractions. Okay, it's just not going to happen. Okay. So scary math. Okay. I know from personal experience because I live with two teenagers who I've had to teach how to factor fractions. And they just go under the table. They go under the kitchen table and they like crawl into the little fetal position and start crying. And they're like, why are you torturing me, Dad? Why are you torturing me? I'm sorry. Okay. I want you to be smart. Okay. I want you to be smart. Okay? I want you to produce better iPhones. Better technology, okay? I need my PS5 and my PS6 and my PS7, okay? That's why I'm forcing you to factor fractions, okay? That's what I need. I need my personal necessities, okay? I need my Gears of War, okay? If you don't give me my Gears of War, I go through withdrawals and it becomes a huge issue in my house. I need my Counter-Strike. I need my Modern Warfare. I need my outlet. Okay. If I can't pop aliens' heads off, I'm just not a happy camper. Okay. It's just you know, if I can't play my BioShocks, it's just not happening. Okay, anyway, I digress. Okay, so let's factor this thing. Let's factor this thing. I personally use the AC method to factor. Okay, and the AC method is I'm going to multiply 2 times -5, and I get -10. And then I ask myself, what will multiply to -10 but add to -3? And lo and behold, that's -5 and 2. This one's easy. Okay, and then what I do is I take this -5 and 2 and I replace the middle term with these two values that have the variable x. And I say, oh, okay, this is 2x squared minus 5x plus 2x minus 5. Now, did I change anything? Did I get anything for nothing here? No. I merely rewrote the -3x as -5x plus 2x. That's all I did. So now what I'm going to do is I'm going to do something called factoring by grouping. I'm going to take the first two and I'm going to factor. I'm going to say, factor out an x from both of these guys. Okay. And I get 2x minus 5. And then I'm going to factor out the common factor from 2x minus 5. Well, that's 1. And so this becomes 1 times 2x minus 5. And now I have identical twins. And what I can do with the identical twins is that I can factor them out. So I'm doing factoring, factoring, and then factoring. It's like factoring inception. But once I get my identical twins, I'm pretty much done with the problem because I get 2x minus 5 times x plus 1. And that's how I factor. And I'm going to set that equal to 0. That was easy.
That was easy.
It was, thank you. Okay, that's what I said. That was easy.
That was easy.
Okay, so let's take 2x minus 5 and set that equal to 0, or x plus 1 is equal to 0. And so I'm going to add 5 to both sides and divide by 2. I'm going to divide by 2. So x equals 2.5 here, or subtract 1, and I get x equals -1. Okay, so I have two critical values here, two CVs, okay, two CVs, one at -1 and one at 2.5. So I know that I probably have two relative extrema. I have two extreme values here, one at -1 and one at 2.5. Oh, okay. So now how am I going to know, well, one, what are those minimum or maximum values, and are they minimums or maximums? So here's what I'm going to do. I'm going to do the first derivative test on this. I'm going to say, let's look at a number line, and I'm going to say f prime of x. Okay, what's the behavior of f prime of x? And I'm going to say, well, here's 0. Here's 2.5. Right? So 2.5 there. Here's -1. Okay. And on either side of 2.5, I have 2 and 3, right? 2 and 3. Okay. On either side of -1, I would have -2 and 0. So here's the neighbors to -1, and here's the neighbors to 2.5. Okay. And so the derivative is equal to what at -1? The derivative is equal to what at -1? What is the derivative equal to at -1?
0.
What is it?
0. Oh, wait, you have to plug it in, right?
Yeah,
I thought you were asking about the slope.
I am asking about the slope.
Wouldn't the slope be 0 because that's an extreme point?
Well, it is 0 because that's how we found -1, right? Didn't we set the derivative equal to 0? Right? At the very beginning, we wanted to find our critical values. Well, how do we find our critical values? That's where the slope is 0. Does that make sense? So what's the slope at -1? It's 0. Okay, so that's an extreme value. What's the slope at 2.5? What's the slope of the tangent line at 2.5?
0.
It's 0 as well. Thank you, Giselle. It's 0 as well. That's why I went through all this work, was to find where are our critical values. Now the problem is I don't know if they're mins or maxes. Without graphing it, I would have no idea. But what I can do is I can plug into the derivative, right? I can plug into the derivative these neighboring values, and that will tell me if I'm going from positive slopes to negative or from negative to positive, and that will tell me if I have a min or a max. Oh, okay. So what's f prime of -2? Well, what's f prime? F prime was equal to, okay, this thing here. Okay, it's 12x squared minus, let's do f prime of x. What was that equal to? That was equal to 12x squared minus 18x minus 30, right? That was f prime of x. Okay, and so I want to know, well, what's f prime of -2? Let's plug that in. That's 12 times -2 squared minus 18 times -2 minus 30. And what I'm really interested in here is whether it's positive or negative. We really care less as to what the value is. What's up with what screen? Want me to zoom in? Is that better? Can I refresh? Absolutely. Let's refresh. Is it better? You want me to try to refresh better? Are you good, Oscar? It looks very light. Okay, let me, yeah. I don't know what's going on. I'm gonna leave it for right now. Okay, for rent, what? Yeah, it's not zooming correctly for some reason. I don't know why it's not zooming correctly. But let's go back here, and let's try to recenter it by logging back in. So where is the login? There it is. Okay, and then let us go there and go there. Let's host. Okay, we'll see if this looks any better. I might have to change my display properties if it doesn't look better. Lowering my brightness. Oh, okay. Oh, try lowering his brightness. Okay.
Yeah.
That's a good idea. Okay, so let's see what we got here. Okay, I can also change to a different color. Is the red just not showing up? Do you want me to change to black? I can change to black if you want. So let me share my screen real quick. Okay. Okay, so let me change to black here. Okay, and maybe I'll make it a little darker too. Okay, so f of -2, I really want to know what's going to be, is it going to be positive or negative? That's all I really care about, right? Is it going to be positive or negative? Well, what is this? This is positive. Okay, because isn't -2 squared, right? Isn't that positive 4 times a positive number? What's a negative times a negative? That's positive. And this thing is going to be, what is this? This is positive 12 times 4, which is positive 48. This is
positive
36, right? And this is negative 30. So the resulting value is going to be positive. So I'm just going to write a positive here. Okay, and that is not thicker. Let me go to a thicker line. Okay, there we go. That's better. Okay, so that's positive, positive, 36. Okay, which is positive. Okay, what about f of 0? Oh, that one's going to be nice and easy. F prime of 0. Okay, that means that it's going to be 0, 0, and negative 30, right? 0, 0, negative 30, which is negative 30, which is negative. Okay, so this goes to a negative. So what do we see happen when we go from a positive slope to a negative slope? Didn't it look like this?
It's a maximum.
It's a maximum, exactly. It's a maximum value, okay. So now let's plug in f prime of 2. And we're going to say, okay, so this is going to be 12 times 2 squared. It's going to be the exact same thing that we're going to get when we did -2. 12 times 2 squared minus 18 times 2. Actually, it's not. We're going to get, because of the negative, we're going to get negative this time. Okay, so this is a negative at 2. Okay, because this is going to be minus 30. So this is a negative, this is a negative, and this is a positive. And so we get 48 minus 36 minus 30, which is going to be a negative. Okay, so that's a negative. Okay, and so then at 3, f prime of 3, we're going to get, okay, 12 times 3 squared minus 18 times 3 minus 30. This is 12 times 9, which is 108, minus 36 minus 30. That's going to give me a positive result because these two negatives aren't going to beat out the 108. So that's a positive. So that goes to positive. So what happens here? Well, this is a negative to a positive. Negative slopes to positive slopes. And so that has to be a minimum, right? So the graph is going to be looking like this, okay, where we have a maximum at -1. We have a minimum, okay, a minimum at 2.5. Okay, a minimum value at 2.5. Okay, so let's find our relative extrema here. So at f of -1 of the original function, I'm going to plug in 4x squared. This is the, let's look at the original function. F of x is equal to 4x cubed minus 9x squared minus 30x plus 25, right? Okay, and I'm going to plug in at -1 here. I want to evaluate this at -1. And I want to say, okay, what happens at -1? 4 times -1 cubed minus 9 times -1 squared minus 30 times -1 plus 25. I just want to get this maximum value. I want to know how high does it go up? What is the relative extrema here? What is the relative max? And what is that maximum value? Okay, so this is going to be -1 times -1 times -1. So that's a -1 times 4, that's -4. Minus 9, because a -1 times -1 is +1 times a -9 is -9. -30 times -1, that's +30 plus 25. Okay, so this is -13 plus 30 plus 25. This is 17 plus 25. Okay, which is what am I getting here? 42, is that right? 42, yeah, 42. So what is my maximum value? My relative max, my relative maximum value is 42, located at point -142. So this thing goes way high up to 42. Okay, that's my relative maximum value. Okay, what's my relative minimum value? Well, that occurs at 2.5. Okay, and that's a relative minimum value. So my relative minimum value is going to happen when f is 2.5. So we'll plug that in. 4 times 2.5 cubed minus 9 times 2.5 squared minus 30 times 2.5 plus 25. And I can't do this one in my head, but I will just tell you that when you plug this in to a calculator, you'll get -43.75. And so this is my minimum value, my relative minimum value is -43.75 located, okay, located at 2.5 -43.75. Boom. Okay, those are my relative maximums and relative minimums. So you're basically, and you're basically asking, you know, why the hell am I doing this stuff? Right? You're like, what the heck is the point to all of this? Right? You're like, who cares where the relative maximums are and the relative minimums are? Who freaking cares about, you know, any of this stuff? Graduation requirement, right? Okay, well, here's why we care. Okay, here's why we care, because we want to maximize what in business? What do we want to maximize?
Profit.
Profit, exactly. We want to maximize our profit. Exactly. Show me the money. Show me the money. Okay. I want to maximize my profit. So if you give me a profit function, right? a profit function, which is a revenue function minus a cost function. And I say, oh, okay, the profit function here, let's say that P of X is equal to, okay, come up with my profit function here. Okay, is 2x cubed minus x to the fourth. Let's say that that's my profit function, right? After, say the revenue function is, let's say that R of x is equal to 2x cubed and the cost is equal to x fourth. And I want to know for how many units am I going to maximize my profit? Does that make sense? How many units do I maximize my profit? Okay, so what are we going to do? We're going to want to find our critical value, right? We're going to want to find the critical value. Well, where's the critical values on this? Let's take the derivative and set it equal to 0. Okay, so let's do P prime of x is equal to, this is going to be 6x squared minus 4x cubed. Okay, and I want to set that equal to 0. Oh, okay. Okay, and so sorry about that. So now let's factor out of this a 2x squared. Okay, so we have 2x squared. That's going to be a 3 minus 2x, right, is equal to 0. Okay, 3 minus 2x is equal to 0. Cool. Okay, now let's set these equal to 0. 2x squared is equal to 0, or 3 minus 2x equals 0. Right? Okay. And so I'm going to divide by 2, x squared equals 0, which means x equals 0. Okay, I'm going to toss 3 to the other side. That becomes negative 2x equals negative 3, divide by negative 2. We get x equals 1.5. So we've got 2 critical values here. One of these is going to be my maximum value, my absolute maximum value. They both could be maximums, but one will be a bigger maximum. One could be a minimum as well, okay? And one could be a max. Okay, but at least one of these is going to be our most maximum value. Okay. So let's see what happens here. How am I going to know which is which? Which one is the max and which one's the min? Well, we're going to do our first derivative test. F prime of x. F prime of x at 0 is 0. F prime of x at 1.5 is 0. Okay, the derivative is equal to 0 at 0. The derivative is equal to 0 at 1.5. Okay. Okay, and so so now we're going to go on either side of these, and we're going to test the points on either side. Okay, so a good point to test here would be negative 1, 1, and 2. Okay, so I want to know what's f prime of negative 1. Well, what was f prime of x? F prime of x was, or p prime of x, I should call this p. Okay, p prime of x was this guy here, negative 6x squared minus 4x cubed. So maybe I'll bring that down so I have it for reference. We have p prime of x is equal to 6x squared minus 4x cubed. Okay, so what's p prime of negative 1? That's 6 times negative 1 squared minus 4 times negative 1 cubed. This is going to be 6 plus 4, which is 10. Okay, so that's positive 10. Okay, so that's positive, okay. Okay, so it's going to go from positive to hopefully negative. It will be a maximum. That will be good. Okay, hopefully. We'll see. We'll see what happens. We'll see what happens. If it goes from positive to positive, it doesn't have any change. There's no change. So let's see what happens at 1. Let's do p prime of 1. Okay, p prime of 1 is going to be 6 times 1 squared minus 4 times 1 cubed. Well, that's just 6 minus 4, which is positive 2. There was no change. Okay, there was no change. So if you look at this graph, okay, at 0, we were at 0. So it would look like this. It would come up here, it would touch at 0, 0, and then it would continue to go up. And only until we got to 1.5 would it start going back down. Okay, now it touches and it goes 0 for a split second. The derivative goes 0 for a split second at 0, but then it just continues to go back up. There is no real change there. Okay. It goes flat for 1 second. Okay. Okay, so what about p of 2, p prime of 2? What happens there? This is 6 times 2 squared minus 4 times 2 cubed. Well, 2 squared is 4, 6 times 4 is 24. 2 cubed is 8, 8 times 4 is 32, and this becomes negative 8, so that's a negative. So where did it go from positive to negative? At 1.5. And what do we know what happens when we go from positive slopes to negative slopes? We get a maximum value. Okay. So our max occurs when x is equal to 1.5. And that maximum profit is p of 1.5, which is, if I plug it into my original function, that was 2 times 1.5 cubed minus 1.5 to the 4th power. If I plug that into a calculator, I get 1.6875. 1.6875. Okay, and we could say that that's in dollars if you wanted. Okay, that your profit function is going to attain a maximum at this. Okay, maybe this is your profit per cup of coffee. I don't know. Okay, so when you're selling 1.5 units, okay, per customer, your profit per customer is 1.6875. Say that you know a customer walks in into Starbucks and buys coffee. How much profit is made per customer on average? Okay, and the average value would be 1.5 cups. Okay, some people come in for 1 cup, some people come in for 2 cups. The average number of cups of coffee that these people are buying is 1.5. And what's the maximum profit that Starbucks can make? Well, it's at 1.5 cups of coffee per person, and that's $1.69 per cup of coffee. That's their profit. They're walking away with $1.69 per cup of coffee. Okay, or per 1.5 cups of coffee purchased, I should say. Okay, it's their profit per purchase. Okay, how much profit is made per customer, Okay, the max profit per customer is $1.69. Oh, there you go. Okay, every one that they come in, they're making $1.69 in profit. Okay, you're not giving away the coffee for free, and it takes materials to make the coffee, but on average, they're making $1.69 in profit for every cup of coffee, every customer that walks in their door. Does that make sense? Good stuff. Okay, let's do one last thing today. Okay, I want to talk about the second derivative function real quick. Okay. Okay, so let's talk about the second derivative test real quick. Okay, the second derivative test. Okay, if f prime double prime of 0, or sorry, of c, of my critical value, is greater than 0, if it's positive, my second derivative is positive, then the function is what we call concave up. And a minimum value and a relative minimum occurs. At C. Okay. So if the second derivative is positive, it's concave up. And what does that mean? Concave up. It's concave up is like a cup. Concave up. Ooh, that's kind of nice. Concave up is like a cup. Concave up is like a cup. Concave up is like a cup. Okay, so you got to get that in your brain. Concave up is like a cup. Concave up is like a cup. Okay. Well, what do you think concave down is like? Concave down is like a frown. Okay, concave down is like a frown. Concave down is a frown. Concave down is upside down, frown. Sounds good? Okay. So upside down is a frown. So we could say that if, if f double prime of c is less than 0, if it's negative, if the derivative is negative, second derivative is negative, then the function is concave down. And a what occurs? What's going to occur when we have a frown? When we have a frown, what's going to occur? Very good, thank you, a max. Concave down and a relative max occurs at C, okay? If the second derivative is equal to 0, something very special happens. If the second derivative is equal to 0, we call this an inflection point. An inflection point occurs, and that is when we change concavity. That is where concavity changes. We go from concave down to concave up. And we say, ah, this point here is an inflection point. Where concavity changes. It's where concavity changes. Second derivative equals 0, concavity changes there. And so we go from concave down to concave up, or vice versa. We could do the exact opposite as well. Inflection point is right here, from concave up to concave down. Does that make sense? So far, so good? Didn't freak anybody out? Okay, let's do one last example, okay? We're good? Okay. Okay, this is advanced calculus, by the way. You're learning advanced calculus. Okay, so I'm just trying to make it as simple as possible. Exactly. So they're like, how do you know? How do you know when you're a good instructor? I usually tell people when you can explain calculus to your grandmother, then you're a good instructor. Okay, if you can explain calculus to your grandma, then you know your stuff. Or a 5-year-old. No, you can't explain calculus to a 5-year-old. That's just, there are some things that are just beyond my power as a lifelong educator to do. Okay, I can't teach my dog to smile, and I probably couldn't teach calculus to a 5-year-old. So they can play the piano. Yeah, the freaks of nature can. Okay, I mean, there's, yeah, sure, you got the Mozarts that sat down at a piano and just started playing, never taught, started playing. But those are your freaks of nature, right? That's not your average person. Okay. So, and am I calling Mozart a freak of nature? Yes, I am. Yes, I am. Do I enjoy his music? Yes, I do. But he was still a freak of nature to just be able to look at a piano, hear the notes, and then be able to play it. Like, that's like an autistic savant. What? How the hell did you do that? Okay. Some people can just play. Some people can just play. Some people just sit down and they can play. And the rest of us, mere mortals, we have to be taught. And we have to practice and practice. And then practice and practice and practice and practice and practice and practice and practice. And practice 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 some more. And then practice and practice and practice and practice and practice some more. So it really kind of pisses me off when somebody comes up to me and says, oh my gosh, you're a math professor? You must have an incredible gift. Because what does that do to the hundreds of thousands of hours that I've worked my ass off to get to my understanding of this material? You just discounted everything that I did to work for anything that I ever accomplished. Oh, it's just a gift. I'm like, no, buddy, I'm no smarter than you are. I've just spent hundreds of thousands of hours going over and over and over and over this material because I fell in love with it at a very young age. And I have a litany of people in my life that will attest to the fact that I am dumb as rocks when it comes to a lot of other things. And so don't ever discount somebody's ability because you think it's just a gift. Those are for the superhero, the superheroes, the ones who aren't mortal. For the rest of us, we pick something that we love and we do it because it inspires us. And it's something that we enjoy. So anyway, thank you for listening to that. But it gets under my skin when people are like, oh, you must have a gift. Like, oh yeah, because what I did was I actually went to UC Irvine. I pulled up in my little car and said, hey, I really like to get a master's in mathematics and a PhD in education. And could you please give me those degrees? I really like this stuff. Could you just hand them over, please? And they're like, oh yeah, sure, I'll just hand them over. I'll just give them to you. Sure, there you go. No, that didn't happen, right? That didn't happen. It wasn't the case. They're like, no, you're gonna have to earn this stuff. You want anything in life that was ever worthwhile, you got to earn it. It's no gift. Anyway, I digress. You probably get the point. Okay, number three. Number three. Okay, let's graph. Okay, f of x is equal to x cubed minus 3x plus 2, labeling all relative extrema and inflection points okay, graph f of x is equal to x cubed minus 3x squared, labeling all relative extrema and inflection points. Okay, so let's see what this looks like. Okay, first I want to get my relative extrema. Okay, so that's going to be f prime of x is equal to 3x squared minus 3. Okay, and I'm going to set that equal to 0. Okay, so now I'm going to factor out the 3, and I get x squared minus 1 is equal to 0. I'm going to factor the x squared minus 1. And I'm going to say, well, what number is going to get me 0 here? 1. What number is going to get me 0 here? Negative 1. So what are my critical values? My critical values are 1 and negative 1. Okay, those are my critical values. Okay. So 1 and negative 1 are my critical values. Okay. Well, that's kind of cool. Look at our number line here. At negative 1, I have a critical value. Derivative is equal to 0. I'm going to put 0 in the middle. And then at 1, I also have a critical value. Okay, so those could be my maxes and those could be my mins. I don't know which is which. I don't know which one's my max and which one's my min. Now I can use the second derivative test to tell me what's my max and what's my min. Okay, well, what's the second derivative here? What's the second derivative? Let's take the second derivative of this thing. Well, that's just 6x. That's just 6x. Okay. So what's f double prime of negative 1? Isn't that negative 6? And negative 6 is a negative value, which tells me that it is a frown. Okay, which means that it's concave down. Okay, so this is concave down, which should tell me that at negative 1, what do I have? Do I have a max or a min?
Max.
I have a max, exactly. Okay, so this is the max. So at negative 1, when x equals negative 1, I have a maximum value. Okay. Okay, what about when x is equal to 1? Is that going to be a max or a min?
Min.
Yeah, that's going to be a min, because this is going to be, I'm going to plug this in, that's going to give me 6, right? And that's a positive number. And so that's concave up. So this is concave down. And this is concave up, which means that I'm going to have a minimum value there. Oh, that's cool. Okay. Okay, where is the inflection point going to occur? Where's the inflection point going to occur? Where's the inflection point? The inflection point occurs at f double prime of x equals 0. That's where the inflection, well, what was f double prime of x? Wasn't it 6x? So at x equals 0, I get an inflection point. Because if I solve this for x, if I solve, let me do it like this. F double prime of x equal to negative 6x. And I'm going to set that equal to 0. That's going to give me my inflection point. This is where the concavity changes. From concave down to concave up. Okay, so from concave down to concave up, it's going to change. Oh, okay. So this is my inflection point.
I think it's supposed to be positive 6x for the f double prime.
Oh, thank you.
Yeah.
same result, but thank you. Yes. Okay, I was just looking on the wrong line. Okay, so that's where my inflection point is going to occur. Okay, well, what was the original function? F of x is equal to x cubed minus 3x plus 2, right? Okay. So now I just want to plug in these values. What happens when the function is at -1? Well, I get -1 cubed minus 3 times -1 plus 2. That's 1 plus 4, or sorry, -1 plus 4. Sorry, -1 plus 3, I should say. -1 plus 3 plus 2. -1 plus 3 is 2. 2 plus 2 is 4. So that's 4. Okay, what's f of 0? Well, that's going to be 0 cubed minus 3 times 0 plus 2, which is 2. Okay, and then what's f of 1? Okay, what's f of 1? Okay, f of 1, okay, is equal to, okay, 1 cubed minus 3 times 1 plus 2 equals, what is it equal to?
0.
Yeah, it's 0, exactly. 0. So I'm at the point -1, 4. This is my maximum. At the point 0, 2, this is my inflection point. And at 1, 0, this is my minimum value. Okay. So let's get to graphing this thing. Okay, so at -1, I'm at 4. 1, 2, 3, 4. -1, 4. I don't like that. Okay, -1, 4. 1, 2, 3, 4. Okay. -1 at 4. Okay. And then at 0, I'm at 2. At 0, I'm at 2. Okay. So that's this guy here. Boom. That's the y-intercept. 0, 2. Okay. So 0, 2. So it looks like it's coming down like this. Okay. And then at 1, I'm at 0. Okay. So at 1, I'm at 0. So it's coming down like this. Okay, but I know that this guy is a maximum, so it's got to turn. It's got to turn direction here. And then this guy is a minimum, so it's got to turn direction there. Oh, okay. So this is just a sketch of what it's going to look like. This maximum is at -1, 4. This inflection point is at 0, 2. That's where it changes from concave down to concave up, right? Concave down to concave up gets changed there. And then this point is my relative minimum, which is at 1, 0. Oh, okay. So let's see, my graph's not going to be as good as if I were to plot a lot more points, right? You could do a t-chart here, x and f of x. You could plot a ton more points on this and get a much more accurate graph. But this is just a good sketch. If I really wanted to go the extra mile here, I would just share my screen on Desmos. And I would say, let's just go to Desmos and let's graph this thing and see what it looks like. Okay, so what is this thing going to look like? Okay. And I'm going to graph this. This is going to be f of x. Right here. I just want to do f of x is equal to x cubed, okay, minus 3x plus 2. Ooh, I like this graph. This is a good graph. Okay, so where was my x-intercept? At -2 and 1. Okay, where's my y-intercept? At 0, 2. Those are my x and y-intercepts. I could have got my x and y-intercepts too. We could go back and look at the original function and get those easy by just setting the original function equal to 0 and setting the value equal to 0. You know, x equals 0 would give me my y-intercepts. Maybe we'll do that real quick. Okay, so I don't know why I'm just not sharing my screen. I should just share my screen. Okay, where would be this x-intercept here? Where's that x-intercept? Okay, well, that would be when f of x is equal to 0. What was this is x cubed minus 3x plus 2 equals 0. Oh, that'd be really hard to find because this is not factorable. Okay, so that's fine. So we could just use the graph, okay, to get that. Yeah, well, that's not going to work, but that's okay. Okay, let's go back to the graph here. Okay, what's my relative max? Where did that occur? Oh, it occurred at -1, 4. Boom, just like we had shown. Okay, where's our relative min? Oh, at 0, at 1, 0. Where's our point of inflection? Where does it change from concave up to, or concave down to concave up? At 0, 2. Okay. Okay, that's all I have for today. I'll see you guys on Tuesday.
Thank you, President.